Dear students, here you can see a copper wire is twisted continuously in this manner, and the structure thus obtained is known as solenoid. So what is solenoid? A solenoid is an insulated wire which is wound in the shape of a helix. So a solenoid is an insulated wire which is wound in the shape of a helix. So the name of this structure is known as solenoid. So we know that whenever a current passes through a conductor, there will be a magnetic field, is it? So while passing current through this solenoid also, there will be a magnetic field. Then how can we find the pattern of magnetic field around a solenoid? Yes, for that we can sprinkle this iron powder on this glass plate. So on passing current, we will get the magnetic field lines by the iron powder. So here you can see the magnetic field lines, and based on this we can draw the magnetic field lines around a solenoid. So here you can see the magnetic field lines are entering this phase, and it goes along the straight way and it leaves the another phase, is it? And it again goes around this and again enters this phase and again it leaves this phase. So in a solenoid there are two phases, one is at this phase and another one is this phase. So this solenoid is connected to a battery. This is positive end and this is negative end. We know that current flows from the positive end. So current moves along this direction, and here you can see then it moves along this direction and it goes along this, and finally it comes along this phase to the negative end. So if we consider each phases separately, you can see the direction of the current is from here to here. That is, the direction of the current here is clockwise direction, is it? The direction of the current here is clockwise. So in the previous class we studied, when the current is moving in the clockwise direction, that phase acts as a south pole. So this phase of this solenoid acts as a south pole, and here you can see the current is moving in the anti-clockwise direction. So that phase acts as the north pole. So both end of this solenoid act as the north and south pole. So here you can see the field lines are entering this south pole, and here you can see the field lines are coming out from this north pole. So comparing this with the bar magnet, you can see the field lines are entering into the south pole. Here also you can see the field lines are entering the south pole. Here you can see the field lines are coming out from this north pole, and here the same you can see. So we can say that whenever a current passes through a solenoid resembles like a bar magnet. So there are in the case of solenoid also there will be a south and north phase, and in the case of bar magnet also there is a south and north phase. So when the current is in the clockwise direction, this phase of the solenoid acts as south pole, and when the current is in the anti-clockwise direction, this phase acts as the north pole. And there will be a strong magnetic field inside this solenoid, and if we keep a iron nail inside this solenoid, then what will happen? This iron nail become a magnet. So if we remove the current, if we remove the supply of current, then it will lose, the iron nail will lose the magnetism, and if current passes through this conductor, or if current passes through this solenoid, then this iron nail will become magnet. So this iron nail will get a temporary magnetism only when the current passes through.